Have you ever just watched a huge flock of birds wheel and turn in the sky and thought to yourself, how do they do that? There's no leader shouting commands. Well, it turns out the secret isn't some single brilliant mind, but a kind of collective intelligence that we're only just beginning to really understand. So let's dive into the hidden rules that govern these amazing smart swarms.
Okay, think about this. How do hundreds of honeybees, all with different ideas, somehow manage to agree on the one perfect spot for a brand new home?
And what about a school of fish? How do they move with such incredible precision that they can change direction in a split second, looking like one single shimmering creature?
Well, the answer to all these questions lies in this one fascinating phenomenon. So what exactly is the secret of the smart swarm? All right, let's start by unraveling this mystery. It's a concept that really challenges our normal ideas about leadership and control. It suggests that true intelligence can actually bubble up from the bottom without any single leader at all.
So the first big clue is that there is no leader. No one's in charge. I mean, think about pigeons in a park, right? When they all take off at once, there isn't one pigeon squawking orders. Instead, each bird is just paying super close attention to its immediate neighbors and following a few simple impulses.
And this gets us to the core definition from author Peter Miller. A smart swarm is basically a group where all the individuals are just responding to each other and their surroundings. And this collective response is what gives them this incredible power to handle unexpected changes and challenges.
Okay, so if there's no leader calling the shots, there has to be some kind of code, right? A set of simple, underlying rules. And believe it or not, researchers actually managed to crack it.
The big breakthrough actually came way back in 1986. A computer graphics researcher named Craig Reynolds was so fascinated by this that he built a simulation. He called it BOIDS, short for bird-like objects, to see if he could actually recreate this behavior on a computer screen.
And what he discovered was, wow, it was amazing. All of that complex, completely lifelike movement of a flock could be created with just 3 ridiculously simple rules programmed into each BOID. 1, don't bump into your neighbors. 2, try to match their general direction. And 3, don't stray too far away.
That's it. And get this, you've almost certainly seen this technology in action without even knowing it. Reynolds' incredible algorithm was the magic they used to create those super realistic swarms of bats and that massive marching army of penguins in the 1992 movie Batman Returns. How cool is that?
But that Hollywood magic was just the beginning. Proving these simple rules could work in a simulation was the key that unlocked their potential for the real world. And now, those exact same principles are being used to give intelligence to actual physical machines.
So why is this such a game changer for robotics? Well, a swarm has these huge advantages. It can act like a giant mobile sensor network. It's super resilient. If one robot fails, who cares? The group just carries on. And crucially, it has decentralized control, which means there's no single leader that can be taken out, no single point of failure.
So to put this to the test, researchers launched a project they called Sentibots. Their goal was to see if a big group of robots, in this case 66 of them, could work together on a really complex mission.
So here was the mission: autonomously search an entire office building and find 6 hidden targets. The swarm spread out, explored, communicated with each other, and in just 30 minutes they had successfully found every single target. The way they communicated was just beautifully simple. It was like a new version of those original flocking rules. As one robot passed another, it would essentially say, "Hey, I've already checked out that part of the building. You should look somewhere else." This simple sharing of local information led to an incredibly efficient group effort.
And the potential applications for this stuff are just staggering. I mean, we're talking about swarms of first responders searching burning buildings before firefighters have to go in, or teams of robots locating hostages, or even examining hazardous chemical spills. The possibilities are truly transformative.
But this kind of intelligence isn't just out there in the physical world of birds and robots. It's a fundamental part of the internet that you use every single day.
I mean, just look at how the principles map over. A fish senses danger from a neighbor. Google counts a link from another website as a vote. A school of fish has no leader. The web's collective intelligence is what ranks pages. The same core ideas, responding to local cues and following simple rules, are totally at play.
Google Search is a perfect example. Google doesn't decide what's important. It uses the votes of billions of links, the entire web acting as one giant swarm, to show you what's most relevant.
Wikipedia works the same way, right? It uses the collective intelligence of thousands and thousands of contributors to build this huge free encyclopedia.
So, this isn't just about animals or robots or computer algorithms. This is about us and the incredible power we have when we act as a collective.
As Thomas Malone from MIT says, collectively, we know far more than we've been able to tap so far. We're now building tools that allow massive numbers of people to think together in ways that were just pure science fiction a few decades ago.
But, and this is a really big but, there's a critical catch. A swarm is only smart if its members act as responsible individuals. The wisdom of the crowd totally breaks down when people just start imitating each other or blindly following trends. Think about the difference between thousands of developers collaborating on an open source project versus a stock market panic that's just driven by fear. The intelligence comes from independent people contributing their own unique perspective.
And this really brings it all home. For anyone who wonders if one person's choice really matters, the lesson of the Smart Swarm is a huge, resounding yes. Our individual actions are the simple rules that create the behavior of the entire group, even when we can't see the immediate effect ourselves.
So that leaves us with a final thought. In all the swarms you're a part of, your family, your community, your digital networks, every action you take is a signal to those around you. So the question is, what part will you play?